Hello viewers. Today the 6th of July we are going to discuss a lot on questions on calculus. Dear learners, this is part 2 of the revision on differentiation and integration under the topic calculus. I have summarized basic points to know before diving to the calculus question. See the 3-page summary. This is the 3-page summary of the topic calculus. This is the 3-page summary of the topic calculus. This is the 3-page summary of the topic calculus. I think I already informed you about this summary in my first part of the video. This is the second part of the calculus video, so these are the tips before diving to the questions. It is important for the learners to focus on the questions, but before diving to the questions, he should also think of the summaries. But before diving to the question, we must also think about the summaries. We are going to tackle at least 5 questions. We are going to tackle at least 5 questions. These questions are directly copied from the book Made Familiar. You can see our video from our first video. I think I have shown the questions from. Okay, note that it is important as a learner to make frequent revisions on my summary tips on calculus that I have already provided in the video. For one, to quickly differentiate whether question is an integration or differentiation, study the 3-page of my summary on calculus. Therefore, let us begin working on question number 5. As we are question number 1 to question number 6 have been already calculated in our first part of the video. Okay, the question states that the distance s meters from a fixed point 0 covered by a particle after t seconds is given by the equation s is t power 3 plus 6 t power 2 plus 9 t plus 5. A. Calculate the gradient of the curve at t is equal to 0.5 seconds. B. Determine the value of the maximum and minimum turning points of the curve. For marks, this question was set in the KCSE 2008 paper 1, question number 24. See my working sketch diagram. This is my working sketch diagram. Okay, but before we start working on the question, we have to identify the question. This is a differentiation question because of the term maximum and minimum. which maximum or minimum equation is given by dy over dx, which is equivalent to 0. Therefore, say the distance is given by t power 3 plus 6t squared plus 9t plus 5, when m and t is equal, when m t is equal to 0, this is t is equal to 0.5. Therefore, m will be ds over dt. This will give us this s will be equivalent to t power 3 plus 6t squared plus 9t plus 5. ds dt will be 3t squared 3t squared plus 12t plus 9. Then we say t is the same as 0.5 seconds. Therefore, say ds dt is the same as 3 into bracket 0.5 squared plus 12 to bracket 0.5 plus 9. V is the same as ds dt, which is 15.75 meters per second. After calculating this, you get 15.75 meters per second as the answer. We have differentiated for the first part of the question. We have differentiated for the first part of the question. Then we say that for maximum t is the same as 3. Therefore, distance will be t3 plus 6. Here is 4 plus 9t plus 5. Here we have integrated. Note we integrate for the second part for maxima as the above, then substitute with the maxima time given. Hence, we say -3. This is -3. Sorry. We say this is -3 power 3 plus 4 to brackets -3 power 4 plus 9 to brackets -3 plus 5. By solving the quadratic equation, you will realize that t is 5 or -3. Since time cannot be negative, hence time will be 5 seconds. Now that was question number 5, part A. Question: calculate the gradient to the curve at t 0.5. Determine the value of the maxima and minima. This was no okay. This was part B1. This is part B1. Part B number 1. Now part B number 2. This is question number 5A. This is question number 5A, and this is question number 5B number 1. Now we are working for question number 5B number 2. It asks of maxima. Determine the values of the maxima and minima. We have solved for maxima, now we are solving for minimas. But remember, there is a sketch diagram for the whole information. This is the sketch diagram for the whole information. Okay, for minima we say that S the same as -1 power 3 plus 6 brackets -1 power 4 plus 9 into brackets 1 plus 5. By solving the quadratic equation, S will be 1 or -1. Maximum and minimum turning point will be -1 and 1. And this is the answer. This is the answer for part B number 2. This is the answer for question number 5, part B number 2. Now we are in question number 7. Question number 7 states that a farmer had 1,200 meters of wire to fence the 3 sides of a rectangular paddock. The fourth side is a wall. Find the dimension that will give the maximum possible area. Find the dimension that will give the maximum possible area for max. This question was set in the KCSE paper 1, the year 1990, number 15. Number 15. Here we say solution. Then we say let the length of the rectangle paddock be L and the width be W. Then we need to find the value of L and W that will maximize the area of the paddock. According to the question, we have given 1,200 meters of wire fence, 3 sides, which means 2 length and 1 width, or we say 2L plus width is the same as 1,200. We don't consider the fourth side because it's a wall. Therefore we say 2L plus width is 1,200. Width is the same as 1,200 minus 2L. From here we can express the area of the paddock in terms of length. Therefore, length is therefore area is the same as length times width, which is 1,200 minus 2L, which this will give us 1200L minus L squared. By differentiating this expression, we get 1200L minus 2L squared. This will be 1 times 1200 minus 4L. To find the value of L that maximizes the area, we can take the derivative of the area equation with respect to L and set it equation to 0. Therefore, we say that dA dL is the same as 1200 minus 4L is equal to 0. Therefore, this will be 1200 all over 4 is the same as 4L over 4. This will cancel by 4, 1 by 4. This is 300. Substitute L into L plus W is equal to 12. Then you say substitute L into L plus W is equals to 1200. Therefore, say 2 brackets 300 plus W is the same as 1200. 600 plus W is the same as 1200. W is the same as 600. Therefore, area will be 300 times 600, which will give us, this one will be 18 0 0 0 180,000 meters square. This is 180,000 meters, and this is the answer for question number 7. That is the answer for question number 7. That is the answer for question number 7. Now we are going to question number 8. Not really, okay. Question number 8 states that the gradient of a curve y is equals to a squared plus bx at origin is equal to 8. Find the value of a and b if the curve has a maximum point at x is equal to 4. Determine the area of the region bounded by the line x is equal to 0, x is equal to 6, and y is equal to 0, and the curve y is equals to ax squared plus bx for the values of a and b obtained in part A. Okay, these 3 marks. This was a KCSE of the year 1992, number 22. This is my sketch diagram. Then here say solution. Now, by identifying the question, this is a differentiation question. Please refer to my summary tips on calculus in this video. From the question, let us assume the gradient at the origin m is equals to 8 at 0.08. Hence y is the same as ax squared plus bx. Y is the same as negative x squared plus 8x. Find a and b at maxima. X is equal to 4. X is equal to 4, which is the same as x minus 4. Differentiating y is the same as ax squared plus bx. This will give us dy over dx is the same as 2ax plus b at maxima. Therefore, dy over dx is equal to 0. Therefore, we say 0 is the same as 2ax plus b. 0 is the same as 2a into brackets negative 4, plus 8. 0 is the same as negative 8. Negative 8a is equal to 8. This will give us 8a is equal to 8 divided by 8 on both sides. A will be equivalent to 1. That is at maxima. At minima, this is at maxima. At minima, gradient is 0. At minima, gradient is 0. Therefore, dy over dx is equal to 8. Therefore, dy over dx is the same as 2ax plus b. 8 is the same as 2 in brackets 0 plus b. Therefore, 8 is the same as 0 plus b. Which 8 is the same as b. This is at minima, where gradient is 0. This is part A. Part B states that part B, determine the area of the bounded X and the curve and B obtained. Okay. Part B, we're going to tackle part B of question number 8. Here in this paper, we say that to find the area bounded by the line, X is equal to 4, X is equal to 6, and Y is equal to 0. The curve Y is X squared plus bx. We have to see from the first part of A of this question that y is the same as negative x squared plus 8. By integrating area, A is the same as 60 y dx plus 60 brackets x squared plus 8x dx. I think you are following me. Then we say area will be negative, because we are integrating, plus 4x squared six zero. This will give us plus 4 to bracket 6 squared. By using calculator, you will finally get that by calculating this, you get the answer to be 72 units. 72 units. But this is my sketch diagram. The answer is 72 units. So we are going to question number 9. Question number 9 states that a particle moves along a straight line PQ. Its velocity v meters per second after t seconds is given by v is equal to t squared minus 3t plus 5. Its distance from P at the time t1 is 6 meters. Determine its distance from P when t is 3. Okay, 4 marks. This was the cases E 1989, paper 1, number 15. Here we say that if we first identify the type of question. So this is an integration question, because to determine the distance of a particle from P when t is 3, we need to integrate the velocity function from t1 to t2. Logically, it's also integration question, because for us to get the distance, we expect the value to be bigger than when we are differentiating the velocity function. T power 2 is equal to 3t plus 5. This, therefore, we say, for this question, we say that determine the distance. Distance will be, this is from t1 to t3. T1 to t3 would be equivalent to t squared minus 3t plus 5 dt. This will further give us, t plus 3 over 3 minus brackets 3t squared over 2 okay, plus 5t. This is under bracket, this is also under bracket. Remember, this is 3, this is 3t power 3 over 3 minus brackets 3t squared over 2 plus 5t, then multiply by t is equal to 1, 2, 3. Okay, this will further give us, see that our space is becoming minimal, so that we are going to continue from here. We say 3 power 3 into brackets over 3 minus 3 by 3 squared, all in brackets under bigger brackets, but this is over 2 plus 5 times 3 minus, because we are integrating, 1 power 3 over 3 minus 3 times 1 squared into brackets plus 5, then we say by 3 power 3 is 27 over 3 minus 3 power 3 is 27. 3 times 3 power 2 is also 27 over 2, and this is plus 15 over 1, all under brackets, minus 1 over 3 minus, this is 3 over 2, this is 3 over 2, plus 5 over 1, all under brackets. This will further give us, divide by 3, this will be 3 plus this is 13.5 plus 15. This will give us 1 plus 15 over 3, and this here will give us 14.5, and this will give us 16. Remember, this is 16 over 3. Remember, this is 16 over 3 minus 3 over 2, which is 23 over 6, or 3.8. And this one is 14.5 minus 3.8. This will give us 10 point. This one will give us 10.7 meters, because its distance p from its distance from p at time t 1 to 6. Determine the distance p when t is 3. Then the distance is 10.7 meters. The distance is 10.7 meters. These questions are directly copied from the KSSC Made Familiar books. I would like my viewers to subscribe, click the small bell ones, download and share to their beloved ones. Okay, we are going to question number 10. We are going to question number 10. This is the last question for our second part of Calcalus video. Question number 10 states that question number 10 states that question number 10. The velocity v meters per second of a particle in a motion is given by v. It's the same as 3t squared minus t plus 4, where t is time in seconds. Calculate the distance traveled by the particle between time t1 seconds and time t5 the remarks. This was KCC 2003, paper 1, question number 16. This is question was set in the year 2003, question paper 1, number 16. Here we say solution. First of all, we have to identify. We need to identify our, is this an integration or a differentiation question before diving or start calculating it. This is an integration question, though we have been given the equation of velocity to be 3t squared minus t plus 4, but we need distance from time t1 to time t5. Therefore we say t5 1, this will be 3t minus 3t power 3 minus t power 2 plus 4t. By integrating the equation, say 3 1, this will give us minus t plus 4t over 3 over 2 over 1, because we are integrating. Now, difference from t1 time t1 to time t5, we are going to look at the difference from time t1 to time t5. This will be given by time t1 to time t5 will be given by minus plus minus plus 1 over 2 plus this is plus brackets 4 times 1 over 1. This all is under brackets. Therefore, by calculating this will give us 5 power 3. 5 power 3 is 125 over 1 minus 5 squared is 25 over 2 brackets plus 20 or minus, this is 1 2 plus this is 4 minus 4 plus 0.5. This is all under brackets. Therefore say If you add 125 to, if you minus this 125 minus 25 over 2, we get 132.5, or minus 44.4 plus 0.5 is 4.5, which will give us, if you minus 132.5 minus 4.5, you finally get 128. And this is meters, 128 meters, because calculate the distance traveled by the particle between t1 to t time t5 seconds. Now the distance is 125 meters, and this is final answer. Now for my viewers, for your information, this topic is closely related to linear motion, a topic in physics from 3. It is important for our young learners to practice these questions for positive results. Whoever wishes to contact me for assistance, please search in Facebook. Post your question. I value your feedback. Remember to subscribe, click the small bell once, download and share to your beloved ones. Thank you for your time.